Hello everyone, myself Padmasree and my teammate Sri Sanjana are from Computer Science Department. We came up with the project Residential House Price Estimator using flask and ML models. We all know pretty well that people are very conscious when they are buying a new house. Budget plays one among the crucial factors while buying a house. The main objective of our project is to develop a machine learning model that estimates the price of residential house price based on some certain features like location, number of bedrooms, number of bathrooms, area in square feet, and deliver the end users the estimated price. As you can see on the screen, this is the page where users will enter the data and obtain the estimated price.
Now let us fill random data into it. For location, I am selecting CV Raman Nagar. For bedrooms, I am making it as 3. For number of bathrooms as 2. And square feet, I am making it as 300. Now let us calculate its estimated price. Its estimated price is 70,74,601 rupees. Now let us see how our ML model is created. We have created our ML model by applying 4 regression algorithms, that is linear regression, lasso regression, rigid regression, and random forest regression. Firstly, we need to import all the packages that are required for our program. The packages which are required for our program is pandas, numpy. To import them, let us write it as import pandas as pd, import numpy as np. After these packages are imported, now let us import our dataset into our program. To import dataset into our program, we will be using read CSV library from pandas package and importing our dataset into our program and storing it into the data. After once the data is imported, now let us see how many rows and columns does it have. To check how many rows and columns our dataset contains, we will be using data.shape. This gives our rows and columns. We are having 13,320 columns and 9 rows. Now, this dataset will be undergoing data pre-processing process. That means we will be detecting the number of missing values and filling it with some value, and next we will be detecting the outliers and removing the outliers. So let us see how the process goes on. Firstly, we are finding how many null values each feature has. That means what are the value that each rows contains null values. That is, we are using isna function and sum. Sum is used to calculate the how many null values are there, and isna function is used to calculate the null values. So here, as we can see, society has 5,502 null values and balcony has 609 null values. Among all the null values, these both are having the most. So we are removing this null values. After that, we will be filling the missing values. For example, here for location, we are seeing the what are the filling missing values and filling it with fillna function by including Sarajpur road. Like that, in the similar way, we are using it for size as well as for bathrooms as well as for BHKs, and we are filling all the missing values. Next, we are going to detect the outliers and remove it from our data. For outlier detection and removal process, we are using mean and standard deviation method, and we are fixing some range amounted and removing the outliers for both square feet as well as for bedrooms. Once the outliers are removed, the pre-processing process will be complete and a new clean data is obtained. Once the data is converted into clean data, we will be splitting it into training data as well as testing data. So after converting it into training data and testing data, we need to import all the packages which are required for our program, like linear regression, lasso, rigid, random forest, R2 score, metrics, mean squared error, etc. Now let us see the code for linear regression. Here we are using LR variable and importing all linear regression function into it. By predict linear regression, LR gives the linear regression predicted value. Here, once the linear regression predicted value is calculated, we are using all the performance matrix and calculating the predicted value for linear regression. As you can see here, linear regression has R square of 0.85247, mean square of 1119.854, root mean square error of 34.63. For lasso regression, we name lasso and store all our lasso function into it. Why predict lasso says us the predicted value for lasso. Now, for calculating the performance of lasso, we have used MSC lasso, RMSC lasso, and R2 score 2. This gives a performance matrix for lasso. As you can see here, lasso regressions have R square method performance matrix of 0.8414, mean square error of 1289.857, and root mean square error of 35.914. Now, let us see rigid algorithm. Rigid regression, we are named it as rigid, and all the rigid function is stored into it. The value calculated for the rigid is stored as by predict rigid by pi dot predict of x text. Now, in similar to lasso and linear, we are even calculating all performance matrix for rigid regression also, and we can see in the end that R square method for rigid regression is 0.8524, mean square error is 1119.77, root mean square error is 34.6377. Now let us see for random forest. To import random forest into our program, we need to import random forest regressor for sklearn ensemble package. Once it is imported, we have to set random forest regressor to random forest, and similar to the above, we have to predict the random forest value. So to predict the random forest value, we are using y predict random forest and storing pipe.predict of x text into it and calculating all the performance metrics. The performance matrix for random forest expression is for R square 0.8432, for mean square 1274.47, root mean square error 35.699. As you can see here, this shows the comparison matrix for all the three metrics for all the four algorithms, that is linear regression, lasso regression, rigid, and random forest. Now we are plotting graphs for these. So this is our test data graph. This is our linear regression estimator data graph, and this is estimated lasso regression graph. This is our estimated rigid regression graph, random forest regression graph. This is our root mean square for all the regression models, that is linear, lasso, rigid, and random forest. And this is mean square value for all regression models. This graph describes the comparison of R square value for all regression models. As you can see over here, when compared to all others, random forest graph is more clear by predicting it is in the range of 300 to 350, and here the test data value is approximately to 400. So we can say that when compared to all the three algorithms, random forest is having a better, more performance. So this will be considered as our optimal solution, and this will be sent to our Flask server. From there, the user will be getting the solution for it. As you have seen before, the estimated price for 300 square feet, 3 bedrooms, 2 bathrooms in Sivraman Nagar is 70,74,601. Let us see what is its price in real. We have selected here 1300 square feet. So let us see according to it. Here we got is 1300 square feet. 1300 square feet. And it has cost of 71 lakh. And ours is 70 lakh 74,000, which is almost near to it. So by this we can say that the estimated price has a good performance and it is almost a bit near to the original price. That's all for our project. Thank you.